Do you want to elaborate a little bit? I feel like, so doing, like you mentioned, these surveys, electrical surveys, I've seen probably, I would say that over 10% of the boats I walk on don't have that AC ground to DC ground tie. They're expecting, they've either removed it to prevent galvanic corrosion, which you say obviously comes from it, that AC to DC ground tie. And the common one I get from these owners, some of them do this deliberately. Their pushback is, well, I get my AC ground from shore. So why would I do my ground tie to my DC and potentially live straight current corrosion? So what's your response to that? How would you, what's your take on that common objection with doing a AC to DC ground tie on a recreational boat?
Well, you go around any large marina and you look at the shore power pedestals and you'll see signs of burn marks. You look at the shore power cords, you'll see signs of burn marks. And that's because that's an unreliable connection. In our houses, the incoming power is bolted. Everything is bolted until we get to the wall outlets, and they're relatively low powered. In our boats, we obviously can't bolt the shore power connection, so we've got this pin and sleeve connection, which is inherently weak. And then we're in a salt environment, and maybe the cord, when it gets unplugged, somebody drops it in the water and then fishes it back out again, so then we get corrosion. So we've got the potential for a poor connection there. And the minute we get a poor connection on the grounding circuit, we no longer have that safety ground. And then anybody that touches equipment that's got a fault is likely to get a shock, or the fault current's going to find a way into the water. But we simply cannot rely on that connection. So then we provide the additional connection, which is to the grounding circuit, which goes through the water. But then we've created the shock hazard in the water. So then we need the ELCI, the electric leakage circuit interrupter, to mitigate against that shock hazard. And many of those boats, I guess, that you're looking at, which don't have that connection from the AC grounding circuit to the boat's grounding circuit, are probably European-built boats, because for decades,
a lot of
the
them
Europeans
are.
have
That's
put
right.
the equivalent of an ELCI on their boats. They call it an RCD, residual current device. And they've relied on that RCD to provide the shock protection. And therefore, they felt that they didn't need the connection from the boat's AC grounding circuit to the water. However, they changed the European standards if I remember correctly, in 2014 to require that connection to the boat's grounding system and to the water. But European boat builders still to this day will leave it off the boat, which, as long as the RCD is working fine, is pretty safe. But those RCDs can fail closed to where they're not going to protect the boat. And then at that point, you really don't have a path for fault current to get it back to the shore, or not a reliable path.
Yeah, it sounds like those galvanic isolators that used to fail open, and you'd lose your AC shore power grounding connection from a failure in the galvanic isolator when they used to. Now they fail. Now we install the ones that fail closed. But yeah, that used to be a real challenge as well. So if you're curious, again, go on our website and find out more answers and solutions with this sort of setup. And thanks for asking. And thanks for all of you for listening and tuning in.